All right, so we've got a bit of a word problem here. So we're going to need to visualize our solid because we don't have a nice little diagram of the solid. We have got a photo though, so that's pretty helpful. So it says 25 litres of water is poured into a rectangular fish tank, which is 50 centimetres long. We can mark that in, 50 centimetres long. Oh, I got the eraser up. So this is 50 centimetres here, this dimension, and it's 20 centimetres wide. So you can kind of see that in this photo with this perspective, the width might be here, something like that. So the width of the fish tank is 20 centimetres. I don't think this is to scale. And it's 20 centimetres high as well. So the height here, this other dimension, is 20 centimetres. Okay, will it overflow? So basically, if we're pouring 25 litres of water into this fish tank, if we don't want it to overflow, the fish tank's capacity has to be 25 litres or more, okay? If it's less than 25 litres, then it's not going to be able to hold 25 litres of water and the water will overflow. So we need to work out what the capacity of this fish tank is. And the way we can do that is, first of all, we can find the volume of the fish tank. So that's going to be in, well, it's going to be in cubic centimetres because you can see all these dimensions were given in centimetres. So we can find the volume in cubic centimetres and then we can convert that to capacity, okay? Because we know that 1 cubic centimetre holds exactly 1 milliliter of water. So we can go from volume to capacity quite easily. So first of all, let's find the volume of this prism. And it's a rectangular prism, it's a rectangular fish tank. So volume for a prism is going to be the area of the base times the height. And for a rectangular prism, we can say any of these sides is the base. It doesn't really matter. Basically, we're going to have to find the area of one of the rectangles and then multiply by the other dimension. So let's just say that this is the base here. So we're going to have 20 by 50 to find the area of that rectangle. Then we need to multiply by 20 centimetres over here because it's been extended 20 centimetres in a third dimension. So it's just going to be like the length times the width times the height. So 50 by 20, that gives us our rectangular base, our face that we just shaded in. Then we multiply by the perpendicular height. So it's been extended by another 20 centimetres in a different dimension. So 50 by 20 by 20 is 20,000. So our volume is going to be 20,000 cubic centimetres. And then we need to convert our volume to a capacity. So if this fish tank takes up 20,000 cubic centimetres of space, how many millilitres will it hold? Well, we know that it's going to hold the exact same amount of millilitres. So it's going to be a capacity of 20,000 millilitres as well, because 1 cubic centimetre holds exactly 1 milliliter of liquid. So that's nice and easy going from volume to capacity. As long as we're going from cubic centimetres to millilitres, it's easy. We don't have to do anything. But the question is talking about 25 litres, okay? So it's telling us 25 litres of water is poured in. So we need to work out whether 20,000 millilitres is greater than 25 litres or less than 25 litres. So let's convert these mils to litres and then we'll be able to see really clearly. So how many millilitres are there in a litre? There's 1,000, so we need to either multiply or divide by 1,000. And we're converting from millilitres to litres. So we're converting from a smaller unit to a larger unit, which means we're dividing. So we divide by 1,000, and our capacity in litres is going to be 20. 20 litres. So our fish tank can only hold 20 litres of water. If they pour 25 litres of water into the fish tank, will it overflow? Yes, it will, because they're pouring more water into the tank than it can hold. So the answer is yes, the fish tank will overflow.